My full names are Ernest Mwaba. I'm a trainer. I teach my students in automotive electronics and also heavy equipment electronics. I'm going to do a demo that will bring out the logic gates, the main ones that we handle.
Now, in theory, things happen like this. We always say, no, when you push this here, this will be on, this will be off. Now, what I'm going to need, first of all, I'm going to start demonstrating using this one, which is an AND gate. What I want to do is to start with a source, which is the battery. If you look at my battery, or the source, which is the source of my electric energy, I have the positive and the negative. So this is my negative side with a shorter line there, and this is my positive. So from here, I'll connect what I want to the other end. So I'll put this wire indicating that I've connected there. Now, next, now that this has come here, I will need two switches to fit my, to be able to work on my gate. So here I am. I have input A and input B. To represent the inputs, I'm going to use switches. So I'll have the first switch right here, which is going to be tapping this voltage from here and feeding it there. So I'll make sure it is off because I don't intend to do it right now. Next, I'm going to put input B. Once again, using this other one here, this other switch. So this is my B. This is my A. Now, if you look at this circuit, it will not demonstrate anything because we need something that can be turned on. So I'm going to use a light emitting diode. This LED is also coupled with the 470 ohms resistor. Of course, that's the standard, the size of the LED. Now here, I've connected it like that. So next, I can just put it right here. Just want to make sure they flow to the other end. This sequence doesn't matter. I can even put it here. It's one and the same thing. I just want it to be secured in the middle here to make it at least standard so that it's not very far from the other end, but right in the middle. Now, so here what I have a battery which is supposed to feed A and B. Now we still have one problem. The IC, or rather this same component which we are using below there, is turned off. It needs to be turned on. So this one has a provision for that. This is where we've been told there's a V, there's a positive voltage. We're supposed to feed that positive voltage right there. So I'll feed it here, and I can tap it straight from the battery. The amount of voltage coming from here is safe for this component. That's why I'm tapping it like that. Next, as it is, even if I start demonstrating, this is an AND gate, I put the A on, I also put this at logic level 1, there's nothing because this whole circuit is off. There is no power from the main source. Now, as per procedure, whenever we're dealing with these electronic components and even electrical components, we check twice, or as they say in mechanics, that measure twice, cut once. So we counter check. I will need to counter check the circuit to see to it that everything is sitting well. So here is my battery. I've connected the positive to the positive feed. Again, if I had wanted, I could have even picked this line from there. It's one and the same thing. And I also have this coming here. These are the lines which are feeding both A and B. Now coming from here, I notice O is well connected there. After this, the output has a line which continues through the LED back to the negative terminal, because this is supposed to be a complete circuit for us to light this up. So now that I'm sure that this has been connected according to what we expect, according to the standard, the way we want this to be, then I can safely power up my circuit. So there. Now what this has done is that this feed, this is now a live battery and it has turned on this. I expect this to behave like an AND gate, and we said in an AND gate I need A and B. These switches should be turned on for me to see that light on. If I just turn on A, there should be nothing. Now for a start, you can see that both A and B are off. In our logic language, we can say when we're trying to draw a truth table, we can say that here there is 0 and there we have 0. The output is still 0 because this LED is still off. Next, I will start with A as per standard. I will supply A, but B is still at 0, it's still off. Again, as you can see, the LED is still off. So I will turn off A and go back and put B on. Again, the same thing. This thing is still off. Same sequence we use when drawing those logic, the truth tables. The last stage in a truth table is where we now put 1 and 1, where we turn on both this one and this one. So in this case, I am going to turn on A and B. As you can see, there, our output is 1. We have managed to turn on our LED, demonstrating that this is an AND gate. This is how an AND gate is supposed to operate. So it's like in a vehicle you have two sensors. One of them should be about the speed of the engine. The other one should be that somebody perhaps has pressed his foot on the brake pedal. Then a command goes to a certain component that is supposed to feed there, then you have your output. So this demonstrates how our AND gate operates.